An angle is said to be in standard position if these two things are true. Its vertex is on the origin, so we're going to take an angle, put it on a coordinate plane. So when we say the vertex is at the origin, we're talking about this point right here. So the point where the two sides of your angle meet up have to be at the origin. They have to be at 0, 0. Okay? And its initial side is going to be on the positive x-axis. So our x-axis runs this direction. They're saying that it needs to be on this portion of that line. So this is called your initial side. Initial is basically where it should be starting. It has to start on the x-axis for what we are talking about today to be true. Your terminal side is just this other line, wherever it may end up. Okay? That line could be here, it could be here, it could be here, but that's your terminal side. All right? That's what's going to determine how big your angle is. It says if you have a counterclockwise rotation, this is going to be a positive angle. So if you start at your initial side and you go this direction, then it's positive. But if you start at your initial side and you go this direction, then that's going to give you a negative angle. The reason is, if you guys remember, whenever we talk about the quadrants that our plane makes, we've got quadrant 1, 2, 3, 4. So the whole grid goes counterclockwise, right? So that's why if you want it to be positive, you have to go counterclockwise, just like 1, 2, 3, 4 does for our quadrants. Okay? That rotation is typically either measured in degrees or radians. So degrees is what you guys are super familiar with for an angle. Radians is what we're going to be talking about today, okay? And our radian measure is defined here below. It says that the radian measure of this angle AOB is the number of radius units in the length of the arc AB. So whenever I'm talking about an arc, I'm talking about this piece of the circle right here. So what we're doing is figuring out the number of radius units that are making up that length there. It says you can find that using this formula. So your angle, theta, right here, normally some degrees, right, is equal to your arc length, which is the letter S, represents arc length, over your radius, which is represented by the letter R. So now that we have that formula, number 1 says to find theta in radians. Well, according to this formula right here, theta is equal to S over R, right? Where S is the arc. Well, how long is our arc on number 1? 3. So I'm going to plug in 3 for S over R, which is the number representing the radius. Radius, remember, goes from the center to the edge of the circle here. And how long did they say that was? 2. So your radian measure here would be 3 over 2. All right. This one says, so if S is equal to R, find theta. So again, theta is equal to S over R, right? Did they say what S or R was? No, but they did say they were equal to one another, right? So I could pick any number in the world. Let's say we say S is 523. If R is supposed to be the same, does it matter what numbers I put over each other? They all simplify to 1, right? Okay? And then it says here that 1 radian, measure of a central angle whose arc has a length R. So that's what we just found here. This is 1 radian. Okay? So typically, like on the problems that we've done the last couple of days, they don't give you the angle in radians, they give it to you in degrees, right? So let's flip over onto the back and talk about how we can convert between degrees and radians. Okay, well, they give us this formula here to say 360. They use 360 because if you were to go back and look at my coordinate grid here, if I go from the initial side all the way around, that's a full circle, right? So that's 360 degrees. So they're saying if you go all the way around, you've gone 360 degrees. And that would represent your arc length, which they told us on the front is the letter S, over the radius R. Okay? Well, arc length, remember on our circle, was just a portion of the edge, right? Like that part could be the arc length we were looking for. Okay, so that's part of the edge of a circle. Does anybody remember what we call the edge of the circle when we're finding that? Circumference, right? And this is the formula for circumference, right? 2 pi r. So they're saying it's the amount of 2 pi r being taken up, right? If it's the whole circle, then that would be the whole 2 pi r, right? Okay, so keeping that in mind, our formulas for degrees to radian conversion is going to be the number of degrees, so however many degrees they tell you that something is. All you have to do to convert to radians is multiply it by pi over 180 degrees. All right. And if I want to go from radians back to degrees, then all I have to do here is take your number of radians that you are given and multiply that by 180 over pi. Okay? So that's our conversion method there. All right, so just to show you where that comes from, if we look up here at the top, we've got 360, right, would be equal to, if I went all the way around the circle, right, that should be, what would be 2 pi? Because if I multiply 360, this conversion right here, by pi over 180, right, you can put this over 1. Right? So when I multiply fractions, I multiply numerators. So that'd be 360 times pi, right? Over 1 times 180, which would just be 180. And I could simplify that fraction, right? What's 360 divided by 180? 2. So I'd have 2 pi. So 360 is equivalent to 2 pi. All right, I could go the other direction with that as well. If I knew that it was 2 pi, I would multiply by this to turn it back into radians, right? So I'd multiply by 180 over pi. I could put this over 1. My pi's are going to divide out, right? 1 in the top, 1 in the bottom. 2 times 180 is 360 over 1, or just 360, right? Okay, so now that we know that this formula is going to work, we're going to convert these next few problems. So number 3 says to convert negative 225 into radians. So that would be this formula, this formula right up here, from degrees into radians. So I'm going to have negative 225, and I'm supposed to multiply that by pi over 180, right? So remember, when I multiply fractions, I multiply numerators. So that's negative 225 times pi, which would just be negative 225 pi, over 1 times 180. So I need to simplify that fraction. Remember, our calculators do that for us. So we would just put in negative 225 divided by 180. It's probably going to give you a decimal, and we press math, enter, enter, right? Yes.
Do we have to change the mode to radians?
No, because we aren't actually putting in a degree right now. We're just dividing or simplifying numbers. So what do we get? Negative 5/4. Good. So negative 5 pi fourths. Don't forget about that pi in the numerator, okay? Okay. Number 4, I'm converting 315 degrees. So now I need to multiply 315 by 180. So that really means I'm going to have 315 pi over 180, right? And I just need to simplify that in my calculator. So 315 divided by 180, convert that to a simplified fraction. What do we get there? So it'll be 7 pi fourths. So don't forget about that term of pi. Your radians need to have pi in them. Okay? Number 5, now we're converting radians to degrees. So now I'm using our second formula. So I'm going to have negative pi thirds times 180 over pi. Well, what's going to happen to pi? Right. So I've got negative times 180, which would just be negative 180, over 3, which is
Negative 60.
good. So this would be equivalent to negative 60 degrees. All right. Number 6, we're converting 3 pi fourths to degrees. So I need to multiply this by 180 over pi. So my pi's, again, are going to divide out. Okay. I can go ahead and multiply here, or I could simplify. 4 is going to go into 180 45 times. So I could simplify there. So then it'd just be 3 times 45. What's that going to be? Good. Okay, so if I ever need to convert back and forth, these are going to be the two formulas we use to make that happen. Okay? All right, then one other thing we need to talk about here is it says if the terminal side of an angle lies along an axis, the angle is also called a quadrantal angle. So it says to sketch and name some quadrantal angles in both degrees and radians. So the degrees will be pretty easy for us because I know you guys know what a 90-degree angle looks like. So this is my coordinate plane, okay? All right, if I am on the x-axis over here, if my angle starts and ends on this same line, I haven't gone anywhere, right? So that would be 0 degrees. Okay. And to convert degrees to radians, I would multiply that by by pi over 180, right? But 0 times anything is still just 0. So 0 degrees is also 0 radians. Okay. The next axis we would come to would be this one here. If I go from here to here, how many degrees have I traveled? 90. All right, from 0 to that vertical line is 90 degrees. Okay, and then if I wanted to convert that to radians, I look up here, remember, I multiply by pi over 180, right? So that's going to end up being 90 pi over 180. What would 90 over 180 simplify to? 1/2. So this in radians would be pi halves. Okay? What if I went all the way from here to here? How many degrees have I gone? 180. So this is 180 degrees. Okay, and if I convert, I multiply 180 times pi over 180. And what's 180 divided by 180? 1. So this would just be 1 pi or pi, right? Okay, let's say we went all the way from here to here. How many degrees would that be? Oops. 270. So this is 270 degrees. Okay, and if I want to convert that to radians, I'm going to multiply 270 by pi over 180. 270 over 180 is going to simplify to 3 over 2. So that'd be 3 pi over 2. All right, and then lastly, I could start here, go all the way around, and come back to where I started. And that would be how many degrees? 360. Okay, and 360 times pi over 180 would be 2 pi. All right, so any of these would be called quadrantal angles because they're on the x or y axis. All right? Okay, it then says on number 8 to sketch an angle that's 120 degrees and one that's negative 120 degrees. So we'll sketch the positive one first. So draw yourself a little coordinate plane here. All right, remember we said on the front page, if we go which direction it's positive? Counterclockwise. Okay, and 120 would fall in here, right, in this quadrant. So I'm going to draw a line in this quadrant, approximately where 120 would be. And going from my initial side over here to my terminal side would be positive 120 degrees. Okay, now I need to draw a second one that shows a negative 120. So let's draw a second little coordinate over here. This time I'd have to go the opposite direction, right? So I would start here, and I would go all the way to here if I'm going to go negative 120, right? So from here to here would be negative 120 degrees. Okay, and then I don't know if y'all's has it or not. It kind of it deleted what they wanted us to do, but this should say sketch a pi force radians and a negative pi force radians. Okay, well, pi fourths, is that bigger or smaller than pi halves? Smaller, right? So that would be in this quadrant, right? Would be where pi fourths is, between 0 and pi halves. So when I sketch here, my pi fourths would be in this quadrant. So here's my positive one, because I'm going to go counterclockwise. But then I'm also asked to sketch a negative one. So for that one, it should be in here, right? So from here to here would be negative pi fourths. All right. So all we learned to do on here was how to convert using our formulas. And now we have an idea of where those would fall on a coordinate plane, right? Okay.